Hi guys, welcome to this Ralph Williamson 29th of February winter special. So I hope you like that snowy intro. I filmed it earlier this month. So in this video we've got a whole ton of stuff going on. We got a video of Rafael Wood / Lieutenant James Wolfman mapping out Bramble-Thorn Wood a week before the events of Lieutenant Wolfman, Sergeant Pod and the Magic Stone. But first, we have two science experiments. So, the first science experiment is how to measure the speed of light using chocolate and a microwave oven. So, I hope you enjoy. Light is part of the electromagnetic spectrum. This spectrum, at the one end you've got gamma rays, and at the other end you've got radio waves. And in the middle you've got light. Microwaves are also part of the electromagnetic spectrum. Everything in the electromagnetic spectrum all travels at the same speed. If we measure the speed of a microwave, it will be the same as measuring the speed of light. Wave's speed is its frequency times its wavelength. On the back of our microwave, it says it's 2,450 megahertz. So, speed equals frequency times wavelength. As we already know, our microwave oven's frequency is 2,450 million hertz. Microwaves have hotspots, so that's why the food has to rotate. Hotspots are half a wavelength apart. So we get the hotspots, we need to stop the chocolate on the microwave from rotating, so we take out the plate and the wheel and we open the chocolate. We then put the chocolate in the microwave on top of a piece of Tupperware just so it doesn't rotate, and then we leave it for 20 seconds. After 20 seconds we take it out, and as you can see there's lots of different melted spots. I measured between the spots and I found it was 6 centimeters. Doing the equations, I worked out that the speed of light was 294 million meters per second, which is very close to the actual value. Can I just add, this is the tastiest experiment I've ever done. Right, now, on to the next experiment. This is how to measure the strength of gravity using a piece of paper, a pencil, and a camera. So guys, for this experiment, we are going to measure the strength of gravity. Now, gravity is the attraction of one object to another, and you can't really tell just by standing next to another person because compared to the universe, you're quite minuscule. But if we look at a bigger object, like planets, moons and stars, they have enough gravity to pull us down if we jump. And the bigger the object, the stronger the gravity. So Earth's gravity, which is what we're going to measure today, is a lot more than the gravity, say, on the moon, because Earth is much bigger than the moon. The moon actually orbits around the Earth because it's pulled in by its gravity. But the Earth's gravity is nothing compared to the gravity of the Sun. The Sun's gravity can pull in all these planets and asteroids. We are Earth circling around the Sun. So, it's kind of the bigger the object, the stronger the gravity. As you can see, a piece of paper, this is a piece of A4 paper folded in half. Now, the reason why we use an A4, we could use any piece of paper really, but A4 is an exact measurement. So that's why we're using that. But if you measure any piece of paper, you can work this out. Right, so what we're going to do is we're going to place a pencil on the top of here like this. Right, and then what we're going to do is we're going to karate chop under it, and then I'm going to put this into my editing software and put the speed right down enough so I can count every individual frame, and then from that, using G, we're going to work out the strength of gravity. Editing software to work out the time it takes for the pencil to fall. Using Newton's equations for motion, we are going to work out the force of gravity. So the first equation is acceleration equals change in the velocity divided by time. The second one is velocity equals distance divided by time. So acceleration equals 2 times the distance divided by time squared. So we know the distance, which is 297 millimeters, and we know the time, which is 0.24 seconds. Putting those numbers into the equation, acceleration of gravity equals 10.31 meters per second. Now the real number is 9.8, so we are 5% too high, but for an experiment you do at home, that is incredibly good. Why don't you try it yourself? Yeah, amigos. We're approaching the end of this video. We've got one last video coming up, a Rafael Wood clip. But before we do that, I just wanted to mention the other videos that have come out this month. So starting off, we got a film theory, Sir Alfred Hitchcock's Bond theory. There's a book review, Michael Morpurgo's Beowulf book review, and there's a Minecraft video, Welcome to Castle Wolf. So after this one, go ahead and watch all those, and also these videos will all be releasing sometime in the near future, all the videos from this video, and also Rafael Wood episode 3 eggs from the last video. Right, now on to the Rafael Wood clip. So this is Rafael Wood, who is going around telling the new member who's at HQ, who will probably be seen in Rafael Wood 4, and Rafael is mapping out the Bramble-Thorn Wood ready for Lieutenant Wolfman, Sergeant Pod, and the Magic Stone, which is going to come out as Rafael Wood episode 5 sometime in the near future. Right? let's get on with it then.
It's Lieutenant James Wolfman here, reporting from my house in Bramble-Thorn Estate in York. And in a week's time, we will be going to find the magic stone. Me and my sidekick, Sergeant Pod, we are going to find the magic stone. But first, we need to map out the area because there's been a few changes in plan. There's a rival archaeologist group that we discovered which is trying to shut off certain paths so we can't get there. So I'm just going to map out the area today so me and Pod will be able to find it, and also so you at HQ will be able to know exactly where we're going. Now, we're quite lucky because it's going to be very sunny next week, which is going to be good. It's already sunny now, but it's going to get even hotter, which is just amazing for this exploration. So, here I am, here at the end of the estate, about to go this way to Bramble-Thorn Wood. This over here is where we usually go. It's the main way in and out of Bramble-Thorn Wood from Bramble-Thorn Estate. But this area, by the time we come to find the magic stone, the rival archaeologist group will have shut this area off. So we're gonna have to go round a bit of a hilly, rocky, fallen down tree way, which isn't preferable, but we need to find the stone. So, yeah. So, I've come down these alleyways. You can see the last one down here, and now we need to go into the woods. So it's just down a path, just over here. Here we have probably our first and main obstacle on this journey. Over here, as you can see, we've got a fallen down tree, but I think we can manage. It's not too big. So here we've got quite a brambly area, but like I said, the sun is really picking up, so hopefully by next week this will be pretty full of blackberries and flowers and stuff, so that will be good. As you can see, the annoying thing is that this is actually back where we started, but like I said, the rival archaeologist group is going to shut this off. They already closed a few fields, which they're going to open later on, but by that point it will be full of their archaeologists. So yeah, but we will just check it out quickly on our way, but like I said, it's not open yet, so there's nothing really we can do. But yeah, alright. So, behind me here, this is the entrance to the main wood, and this is like, obviously this is like, most of this area of the wood is actually more of a nature reserve, but this is the only area which is like a proper wood, and okay, so I don't think I'm gonna go in there because, you know, I don't wanna spoil the surprise for you when I tell you all about it in a week, because it's not like I'm scared of it or anything. No, I did a whole archaeologist course. I've slid down a sea wall, faced a boggle, so yeah, you know, I'm good. I don't need to be scared or anything. So I hope this was a good report, and yes, I'm very excited for next week. It's going to be very sunny next week. I'm getting a haircut before then at the barber's, so yes, it's going to be great. So guys, I really hope you enjoyed this video, but anyway, please like and subscribe. But for now, this has been Ralph, and I'll see you in the next one.